Okay, so first, the introduction. Natural lakes have irregular shapes, so standard geometric formulas cannot be used. In this course, interpolation methods such as Newton forward divided difference are used to model functions from discrete data points. By selecting the coordinate points along the lake boundary, interpolation and integration can be applied to estimate the lake area.
The problem statement. Taman Tasik Section 7 Shah Alam has an irregular and complex boundary. Standard geometry, formulas and direct calculation are not practical for this lake. This is because the lake boundary contains many data points, making direct calculation difficult. Therefore, the lake must be divided into several sections and solved using numerical methods. Newton forward interpolation and numerical integration are chosen to estimate the total area.
So, there are three main objectives for this project. Okay, first, to apply the Newton forward divided difference interpolation method to accurately model the lake boundary. Second, to calculate the approximate area using numerical integration techniques and evaluate its accuracy. Third, to compare the approximate area of the lake with the actual values and analyze the errors that arise.
Implementation. The lake boundary was divided into 6 sections and several coordinates were chosen along the border to represent the shape of the lake. These points are used for the information process. After selecting the coordinate points, a forward divided difference table was constructed for each section. The first, second, and third divided difference were calculated using the formula were given. Then, using it in the interpolation process. Using the divided difference tables obtained earlier, the quadratic Newton forward interpolation polynomial was constructed for each section, and here is the general form that we use. Next, we calculated the area of each section by applying the integration formula. Once the area of all sections are determined, we sum them together to find the total area. Before that, our user scale is 2 cm equal to 100 meter. If 1 cm means equal to 50 meter, we calculate the approximate area by total area multiplied by 50 meter and 50 meter. Then, the exact area we using box counting method. By 911 units, we got the total area of the box, and we change the unit to meter. After all, we find the relative area by calculate the absolute area, and we just divide the answer. The final answer is percentage is 11.53%.
Next, for the result and discussion, the lake area was estimated using the Newton forward divided difference interpolation, where the lake was divided into 6 sections, each consisting of 4 coordinate points to improve the accuracy. Each section generated a quadratic polynomial which was then integrated to obtain the area. The total calculated area was 32.2371 cm square, which corresponds to 18,592.75 meters square using the scale 2 cm equal to 100 meter. To verify the result, the box counting method was applied, yielding 911 box equivalent to 91,100 meters square. The comparison between both methods shows a relative error of 11.53%, indicating that the results are consistent and that Newton forward interpolation is effective for approximating an irregular shape. So lastly, for the conclusions, what can we conclude from this project are the objective of this project was successfully achieved. The lake area was estimated in a systematic and structured way by dividing the lake into sections. The result obtained are more reliable than manual estimation despite small approximation errors. This project also highlights the practical application of numerical analysis in solving real-world problems.